Greetings once again and welcome to the new Calculus channel. So I'm going to be addressing a question or a comment that was asked by somebody, question and comment, somebody on our Discord server. So let me read it out to you. It concerns this video on explaining the closed form trigonometric ratio formulas. So let's read the comment and then we'll discuss it. So it says, so forgive me if I'm misinterpreting this, but finding the sine function is through the ratio of the circumference of the circle to the secant line. That is also the hypotenuse of a right angle triangle that makes up a quarter of the circle. But instead of it being pi, it's any point on the circumference. And instead of it being square root 2, it's the function, because trigonometry is applying the right angle triangle to that of a circle. Okay, there is a discoverable ratio between the circumference and the hypotenuse. He's asking a question, and with other functions just being the result of simple operations that derive from said function. So here is my response to that. How do we use this method? So first of all, we choose an angle stated as radical units. We don't even need pi, by the way, or a circle. So let's go back to these diagrams. So over here, I've still used the circle just to demonstrate that you cannot cut this hypotenuse into equal parts, because there is no isomorphism between this hypotenuse and this circular arc. And what does that mean? That means simply that if you have that secant that I just showed you and the arc like that, then there's no way you can take a distance on here and multiply it by a scale factor to get the arc distance. It would be true, however, if we took this arc and we created a straight line like that, then there would be a scaling possible from the hypotenuse to that straight line, okay? This is another one of the contradictions in Cantor's bijective cardinality theorem, which is a bunch of garbage, because in one case you have, in this case here, you have a bijection which doesn't have a scaling factor because there is no isomorphism, and in this case here there is isomorphism, and so there is a scaling factor from this hypotenuse to this line. Okay, so that's what it means, excuse me, when we talk about dividing or trying to find some kind of relation between the circle circumference or arc and this hypotenuse. There isn't really. And of course, if you have if you cut this directly in half, that's the only time that these two partitions will be equal. Otherwise, what you'll have is, if you have an odd number, then the partitions on the sides will be equal, like this one equal to this one, and the middle one will be something else. So they're not at the same length. Similarly, if I had to partition the right angle, and I don't really care about the circle, there's really no need for the circle or even this at all. Okay, there's no need for that. So even if I had to partition these with when n is even, then of course these middle two ones are equal and the outer ones here will also be equal. So you'll have this kind of property when you try to, I don't know why the pen isn't working. When you have an even number, you'll have this situation. When you have an odd number, you'll have this situation. Okay, so again, forget about the circle, not important. Okay, all we care about, in fact, are the properties in this triangle. Okay, so we don't even care about these. We don't even care about the degrees here. Okay, this is entirely based on uh, straight lines. So how do we find all these values? Okay, so now we tend to think of an angle no more in terms of degrees or radians, but as a distance along this hypotenuse. Okay, so in my response, I said we choose an angle stated as radical units, that is a proportion of root 2. So to speak of 45 degrees or pi over 4 radians, we say that half a right triangle or radical unit is what we're referring to. Okay, so if we just had something like this, then these angles are equal, and they both equal to half a radical unit. Okay, so this is one radical unit, or simply root 2, and these are half of root 2. Okay, that's what that means. So only 0, 1, and half of a right angle have the same measure in degrees and radians. There is no other isomorphism from the secant line, as I've just explained to you, to the quarter circle arc. So, for example, this part of a right angle corresponds to 30 degrees. Right, so this length here would be, in fact, 30 degrees. Okay, equal to 30 degrees, but we don't refer to it like that. We just refer to it as this angle, this particular angle. Okay, and there's no need to do this because we're not considering the circle any longer. So we are measuring this angle in a different way entirely. So how are we doing it? Okay, so when we choose, we don't have to find this value here. We choose it. Okay, so if we choose this value, we know that this line will be equal to this line, right? So we could say 0.51764 squared is going to equal to, and we don't know these values yet, so we'll call them t, and we'll say it's equal to 2t squared, yes? Why? Pythagoras. Which means that t, okay, this implies that t, which is this green length, is going to equal to this value here divided by 2 and the root of all that. And it turns out to be 0.36603. So because this is that value, so will this be 0.6603. And of course, since this is a distance of 1, that is also a distance of 1, this value here is simply 1 minus 0.36603. Okay? And so this is, the green part is the hypotenuse. The magenta part is the adjacent. And from these two, we can find this hypotenuse, right? Just using, again, the theorem of Pythagoras. And now we have all the information we need to determine the sine ratios, the sine, the cosine, all the trigonometric ratios, the tangent, the cosecant, secant, and cotangent. Okay, all the information that we need is now there. So the next thing that I want to say is that if you're looking at this diagram here, it doesn't matter where you place this length. So if you had this length, no problem. You do the same thing, because then this line here would equal to this line here, and the same process is followed. So it applies to any particular length along this diagonal or hypotenuse. Okay, so I hope I've explained it clearly. If you want to look at a better explanation, I have written one up in the detail section over here of this video, and you can read it there. Otherwise, you can join our Discord. We have many interesting conversations, and there are back and forth responses to questions and comments. So if you're not already subscribed, become one. Click like, become a follower on Academia, tell your friends about it, and donate at the GoFundMe page link. Once it reaches at least $500,000, I'll decide on revealing more information. So this stuff is brand new. It's never been published. Nobody ever knew about it. The beauty of this method is that you don't have to use circular geometry. You can learn it easily just with the theorem of Pythagoras and similar triangles and a very basic knowledge of proportion. You don't even need to know anything about degrees or radians. So all this goes, okay? Nothing about that. And uh, it gives you exact values that any infinite series would give you, and even better in most cases, okay? Because the formulas are in closed form. You don't simply iterate or need to find a better way of reaching the precise value. So, I'm John Gabriel. This is a new calculus channel. Till next time, goodbye.